Welcome to Pavithra Laptop Care. One of our PLC students having an issue with the Apple 1278. He has sent schematic. In Wien section has some doubts. So just I wanted to clarify him. See, you want to know the charging IC functions because this particular charging IC datasheet is not available. So that is the reason you want me to clarify those things. Okay, let me check. In this page number 63 and 64 having the charging related information. Here is the DC in battery connectors. It's a page number 63 and 64 P bus supply and battery charger. Here is the charging IC and here is the connectors. First we will check the connectors. 63. See, this is the DC jack. It contains total 5 connector. 1, 2 is the positive, 3, 4 is the negative. Fifth one is the adapter sense, adapter ID in Windows. Correct. See, the 1, 2, the positive one will come through this fuse and finally it will become PPDC in underscore G3H. Next, here 3, 4 is the ground. Number 5, it's the adapter ID. It will come through this. Here is the no stuff. This resistor won't be there. And it's coming to the input for this IC. This IC is a protector IC, protection IC. Okay. For this IC, input is coming from here, from IO. What is that input? How it's generating? See, it's a PP3V42 underscore G3H. This voltage is very important voltage. You have to note down. Here is the supply to this AND gate. What are the characteristics of AND gate? The input A and B should be high, then output will be high. If anyone A or B is a low, then 100% the output will be low. Here A and B has short, means both are same input. It's coming from SMC, BC, AC, OK. Okay. Then if it is a high, then 4 will be high. If it is low, here also low. This is AND gate U6901. It one has 3 leg sort 665. Okay. The output will come to as a VCC to this protection IC. If there is no VCC, there will be no adapter ID. It won't work. It's like a dead, right? Okay. Here we come to know what is the DC jack section. Next, in the same section, see, the most important which I told you know, that is here. 3.425 volts, G3 hot. See, once again I will repeat, it's a G3 hot supply. How it will generate? See, PPDC in we got, right? This one is like B plus. In after CLR we are getting this voltage. But before, once you connect the adapter, this voltage will come. So it has come to the diode, 3-leg diode. The output, some voltage will drop here and output will become this one, PPV in underscore G3H underscore P3V42 G3H. See, it's generating this voltage. For this, it's an input. Okay. Usually what voltage will be there, that also I will tell you. This is the V in. This one is the regulator IC. Regulator in the sense, it's accepting more voltage and finally giving the output this one, PP3V42 G3H. What is the output name? It's a PP3V42 underscore G3H. What is the input name? See, the same name, output name as given, and PPV in underscore G3H is the input. There is a logic, okay, input and output. This is the identification. See here, voltage 18.5 volts they have given, main line. Actually, usually we will get, it's a depends on battery, it's a 12 volts, 8 volts some other volts we are getting 4 volts. 16.5 is the required voltage for this particular laptop. So now you got to know how we got G3 hot. Means here is the V in supply for this. Okay, enable, same voltage is enable, same voltage through this resistor as the tone pin. VCC, one more VCC, it's the feedback. Here also feedback is two feedbacks. Here reference nothing is there, ground. Here is the switch. See, through this switch and through the coil, wherever the switch will get in the buck converters, so 100% you will get the coil. So through this coil, the output is PP3V42G3H. Right. If you want bypass, so one bypass signal also is there, pin number 9. So after this coil, we will get the output. So it's very easy, right? So we got PP3V42G3H. We got two voltage on the input and output. Okay, this is the battery section, battery connector. Here what are the point is very important one. See, 1, 2, 3 are connected to the ground. 4 SM bus clock. 5 system detect, it's a battery detect. 6 is the SDA data. Here is the clock and here is the data. 7, 8, 9 are the battery voltages. See, PPV bat underscore G3H underscore connection. It's a battery voltage. 10, 11, 12, 13 is the ground. Any doubt in this? Of course not, I think so. You understood. Okay. See, here is the ESD diode for protection. Okay. Now we come to the charging section. What voltage we got from the adapter? It's a PP DC in underscore G3H. Right. This voltage is going to 3-leg diodes and becoming charge DC in input voltage for this IC. DC in pin number 2. First point you got it right. So first adapter voltage is coming to through the 3-leg diode and the output is going to the charging IC input. But one more thing you come to know, before this, here it's going somewhere. See where it has come? Here it has come as a voltage divider. Right? Voltage divider means second one should be ground. See, here is the ground. Okay? These all are ground. Here is the R2 and here is the R1 and here is the input, adapter input. Some information has given here. AC in, actually what we saw, here is the voltage divider output is the out source, it's an open drain output for AC in. Here some information has given. What is that? AC in pin threshold is 3.2 volts. Okay, 3.2 volts. Divider sets AC in threshold at 13.35. AC in means this one, threshold. Okay, the main thing is here this point has to be noted, 3.2 volts. If the AC in 3.2 volts more than this, then it will be high. If it is lower than this, it will be low. That is the logic. Understood? AC okay. I will repeat. If it is more than 3.2, then it's a high according to this divider. Okay. If it is lower than this, it will be low. Okay. Now, first voltage is AC direct, means AC in. Second one is DC in. Once DC in and AC in will come, in normal windows region will generate, right? So here VDD, VDDP will generate. What the voltage? Here approximate 5.1 volts we will get. This is the output of this LDO voltage. So 5 volts, see here it has given minimum 5.1 volts. Here also minimum 5.1 volts. Both we will get. Okay, through this 4.7 resistor we are getting this one. What is that? VDDP, and here is the VDD. Next, what we will get at a time, if the condition is true, what is that? AC OK condition is more than 3.2 volts, then this will active, means AC will be in a high position. I comp, V comp, AM on, BM on, means adapter monitor, battery monitor. See, adapter monitor, it's fixed for 20 volts and battery 36 volts. Internally how it will generate, that I don't know, but output will be this much. You can check in this particular pin. Once ACOK is good, this output will generate. It will monitor the adapter things. How? Usually the CLR. You know the CLR, right? In this, which one is the CLR? See, very low resistance. It's a 0.02 ohms, 1 watt. 0612 is the size. It's a very big one, right? So big one is the CLR one. Okay, before that we come back to adapter in. So it has gone to AC OK, right? So as well as it has gone to this particular MOSFET. Which MOSFET it is? Arrow mark up. Here source is the opposite to this particular V in. Source, if source is opposite to this diode, then what we call it is a P channel, right? PRN, I already clarified those things. Okay, it's a P channel. For P channel, the gate voltage should be lesser than source, correct? So lesser in the sense approximate 3 to 5 volts lesser than source. In N channel, minimum 5 to 6 volts greater than source. Here is the source voltage. It's a battery voltage, approximate 12 or 16, whatever it may be. It's lesser than this. How it will happen? See, here is a resistor. Wait, we will check. See, here one resistor. It has gone to pin number 26. See, usually in Windows related schematics, what we will see, there will be a voltage divider. We are giving the V in source voltage from the adapter, right? So here IC itself is generating. This is called little bit special IC. What is that? SL6259. Right? It's easy to understand. Even I also don't know. This is first time I am seeing this. Some common topic will be there. According to that, we have to see. We have to identify. See, this voltage divider is giving from this IC. Means this IC is giving the voltage divider, means gate voltage. First gate, what is that? Name, charge a gate. Here, charge a gate. See, here charge a gate is coming through this pin number 1. Similarly, S gate, okay. For second MOSFET also, the charging IC is giving, correct. So now how many pins got over? DC in over VDD, VDDP, AC in. I come once this voltage is true, means once the gate voltage will generate, then automatically we will get the CLR voltage. Here, see, PP DC in G3H charger, correct. Where it has gone? Here it has gone. This is the CLR voltage, and that particular CLR voltage has come through this MOSFET, okay. And here, what is this MOSFET? Here is the phase. See, that is the input for this high MOSFET. This is a high and this one is low, Okay, once we get the CLR voltage, once we get the gates of this particular MOSFET 1 and 2, then we get the CLR, and then the supply for high MOSFET is ready. Correct. So according to that, even battery CLR also we will get once we connect the battery. This is a battery CLR. See, from battery through this MOSFET it has come, and here is the CLR. PPVBAT G3H charge underscore R. PPVBAT we already got, right, from the battery connector. See, this is CLR. Okay, what we got? What are the left connectors? See, we got CSOP from the battery positive side, negative side, as well as CS in, I mean adapter positive, adapter negative, CLR, two CLRs input positive and negative we got. S gate we got, A gate we got, DC in, VDDP, VDD, and this one, what is that, AC in, ICOM, VCOM. This is the current information comparator, this is voltage comparator. Okay, this one also we got, beam on, AM on. See, AC OK, by default AC OK will generate once AC in is high position. If it is more than 3.2, then automatically AC OK will be high. That's directly going to the where? IO. Right. So now what are the left pins? This one. See here. PP3V, that hot voltage is there now, PP3V 42, that one has given as a input for this VHST, and same input as given as a voltage divider to the cell, charge cell. See, this is the most important one, and one more also is there, that also I will tell you. Here is the charge cell. Okay, in Windows we won't see this cell, right, in normal charging IC, but here is the special IC. So we are seeing this cell, pin number 6. What it does, that we come to know. Cell itself tells it's a battery cells. It depends on one cell, single cell, two cells, three cells. Depends on that cells, this voltage will generate, the output voltage will generate. Okay, if, see, what is the supply? PP3V42G3H means it's a 3.42, right? Here, if it is a floating in the sense, I already made a video regarding this, what is that floating and what is that high and what is the low position in previously, right? In previous video you can check those things. If it is a floating in the sense it's not high or not low, in that condition what it will sense? It will sense battery is a single, means single cell battery. In case of pull down, it's a low, then by default around 8.5, 8.6 volts it will generate. It's a two cells. In case if it is a high in the sense it's a 3.42, then it will generate voltage as a 12 volts to some 14, I think so, 14 or 15 something. Minimum is the 12 volts. So this is most important. According to this only, the output what voltage should come, that decides. Two systems. See, PP bus underscore G3H is the output through the fuse to system. Got my point? So I will repeat. Depending on the cell pin, here you will get the output 4.1 for floating. In case of low, it's 8.5. In case of high, approximate 12 volts. Correct. Initially it will be 8 and slowly it will start to 12. That's it. Right. What are the pins remaining? All are common. Boot. Once these all are okay, you will get the 3 volts, then SDACL will happen. Right. Once step down IC will generate the step down voltage, Then SDACL will start through this SM bus communication. Next, boot internal driver voltage for what? High, low, high gate and low gate driver voltage. Once this voltage generates, it by default through the capacitor as given to the phase. Given or not? Boot, see, through the capacitor given to the phase. Boot common, anywhere you go, it's a buck converter. Boot must and should as given to the phase. Internally, it's a driver to high gates and low gate. Okay, here is the phase. Phase is a common. B gate, see, for battery side, charge B gate. Is there any other MOSFET? For that voltage it is. Here may be the B gate. Charge B gate. Right. What else? Everything almost over. So like this you need to identify the charging IC, pin voltages, what are the first and what are the next. So I already explained all the order wise. Okay, now your turn, you need to check in your laptop what are the voltage is coming, and after that what are the voltage you are getting. So exactly you are facing plugged in not charging, right? See, one more important pin for plugged in not charging. Everyone will neglect this, but I don't know everyone will neglect or not, but this is the reset pin, SMC. Here usually you will get lower than 2 volts. If you get lower than 2 volts, then only in adapter connector will be there, no, there green or orange color light will blink. If it is more than 2 volts, definitely you won't get it. So some charging related issues will be there. Right, see, from these pages it has come. SMC reset means it's IO giving the signal to the charging IC. So once again I will repeat, SMC reset L, if it is a lower than 2 volts, then you will get green or orange light, the charging light in the adapter. Otherwise you won't get it. That's it. It's very simple, right? Thank you very much.